Hello and welcome to this recorded session, a refresher session of number at level 1 and 2 for legacy functional skills. This follows on from part A, so if you haven't watched that already, please watch it first. My name is Shamo Phelps and I am the Curriculum Officer for Maths Functional Skills here at NCFE. We're going to take a look at the subject content for number at level 1 and 2. Then we'll look at percentages, percentage increase and decrease, a number as a percentage of another number, original value after percentage change, and then ratio in terms of proportion, sharing, scale, and we'll end with a short summary. The subject content for the Legacy Functional Skills qualification is taken directly from the DFE subject content statements for these qualifications. We're not covering the full curriculum at level 1 and 2, simply the parts of the curriculum that Chief Examiner reports have found that learners most struggle with. So here is the full subject content criteria at level 1. Obviously, learners do need to cover the full subject content, but this is just a refresher session. So we're just going over the parts that learners tend to struggle with. So this recording will focus on understand and use equivalences between common fractions, decimals, and percentages, and solve simple problems involving ratio, where one number is a multiple of the other. At level 2, we have the full content here. We will be focusing in this session just on understand, use, and calculate ratio and proportion, including problems involving scale, and understand and use equivalences between fractions, decimals, and percentages. I will not differentiate the content of this recording for level 1 and 2. However, if you need an example of the types of questions that will be asked in the assessment at the different levels, there are sample papers available on QualHub. Section 2, percentages. There are many reasons why you might want to find a percentage of a number, for instance, in household budgeting, or to work out the percentage of profit or loss of a company. We'll look at two methods for finding percentage. This first method is my preferred method. It hinges on the knowledge that percent means parts out of 100. So you simply divide by 100 to find 1% and then multiply by the number of the percentage that you want to find. In this example, we're looking at 20% of £550. Perhaps we are in the construction industry and we have received a bill for materials of £550, including VAT. It's important to calculate the VAT amount, as if I'm a registered company, I can claim that money back. So 20% is the rate that VAT is currently set at. So in order to calculate 20% of £550 using the first method, we divide by 100 to start with. 550 divided by 100 equals 5.5. And then we multiply by the percentage we want to find. 5.5 times 20 equals 110. So 20% of £550 is £110. Here's another method to change the percentage into a decimal by dividing by 100 and then multiplying the original number by the decimal. This hinges on the knowledge of equivalences between percentages and decimals. Personally, I would use the first method if I was didn't have a calculator, because dividing by 100 is quite straightforward. Whereas if I had a calculator, I might choose to convert the number into a decimal. So in this example, we want to find 33% of £600, perhaps because we know that our costs are 33%, and we want to calculate our profit. So 33% as a decimal. To find that, we do 33% divided by 100. That gives us 0.33. 600 times 0.33 is 198. So 33% of 600 is £198. So in our particular example, if our costs were 33%, so our costs are £198, then in order to find our profit, we would do 600 minus 198, which would give us £402. We may also want to know a number as a percentage of another number. To find this, we simply divide the first number by the second number, then multiply by 100. So in this example, Alex scored 42 out of 60 in his online assessment. What is this score as a percentage? We do 42, the first number, divided by 60, and that gives us 0.7. 0.7 times 100 equals 70. So Alex scored 70%. It's very important to remember that percentage symbol. Otherwise, we'd be saying that Alex scored 70 when he didn't. There were only 60 possible marks. So it's very important to remember that percentage symbol. There are times when you might be given the result of a percentage change and you'll need to work backwards to find the original value. This is one that learners struggle with the most, and you'll find that many people trying to find out the original value will struggle with this, but it is something that we do quite often have to calculate on a day-to-day basis. So in order to calculate a reverse percentage, there are 3 steps. 1, write the amount you're given as a percentage of the original. 2, divide to find 1% of the original value. 3, multiply by 100 to give the original value. So that gives you the 100% value. I've created this little memory jotter here. So here we have Poodamoo. So Poo is percentage of original. D is actually divide to find 1%. And then Moo is multiply by 100 to give the original value. So we'll take a look at 2 examples of this, put it into practice. So example 1, a garden shed has gone up in price by 15% to £1,610. How much was it before the price rise? So our first step is Poo, percentage of original. £1,610 is the original price, 100% plus 15%. So as a percentage of original, £1,610 is 115%. Step 2, so we've got the D, Poodamoo, D, divide to find 1%. So to divide to find 1%, I divide 115 by 115 to get 1%. I divide £1,610 by 115, that gives me 1%, that's £14. And then if we're looking at the 15%, well, multiply that by 100 to find 100%. So 100% equals £1,400. So the shed was £1,400 before the price rise. To check if that's correct, you can calculate 15% of 1,400. And if you add on 15% of that, you will reach £1,610. A common error when asked to calculate a reverse percentage would be, rather than go through these 3 steps, it would just be to find 15% of 1,610. Now that's not going to give you the same answer. That will actually give you an answer of a value of £1,368.50. So that's the wrong answer. So in order to check that you've done your steps correctly, we can see 1,400, 15% of that, well, 10% of it is 140, so 5% is 70, 140 plus 70 is 210, so 1,400 plus 210 does give us £1,610. In this next example, we're going to look at finding a reverse percentage where the number that we're given is actually less than the original. So Tony bought a dress in the sale which had 20% off. She paid £16. How much did Tony save? So step one, £16 is 80% of the original price. So remember our steps, pu, di, mu. Percentage of original, £16 as a percentage of original is 80%. D, divide to find 1%. So 80 divided by 80 is 1, £16. So that will be 1,600 pennies. So £16 divided by 80 gives you 0.20 or 20 pence. And then if we multiply by 100 to find 100%, we can see that the original value of the dress, the original price of the dress was £20. Therefore, Tony saved £4 as the dress reduced in price from £20 to £16. And again, a common error for this would be to calculate 20% of £16 and then add it on to £16. And again, that will give you the wrong answer. But if we check here, £20 reduced by 20%, or 10% is going to be £2. The 20% will be double that, so that's £4. So £20, she saved £4 and she paid £16. So we'll look at ratio. So ratio is a way of showing a relationship between two or more amounts. It shows you the proportions of the different parts of the ratio that you will need. So when we speak about ratio, the ratio is always given in the order that you say the different parts. So it doesn't matter if one, it doesn't have to be like the smallest number first, it's the way that you say it. So in this example, the ratio of men to women working at the supermarket is 2 to 3. So for every 2 men, we have 3 women working at the supermarket. So as an example, if we need to mix cement, sand and aggregate at a ratio of 1 to 3 to 3, and Rahid is actually pouring, he needs to pour 1 kilogram of cement, he's going to need, for 1 kilogram of cement, he's going to need 3 kilograms of sand, because that's in the second position, and 3 kilograms of aggregate. The ratio will work no matter what units Rahid uses. So even if, if he was going to use 100 grams of cement, then it would be 100, 300 and 300. If he wanted to make 28 tons of cement, then in order to find out the way of mixing that, what you would need to do is divide 28 by, we've got how many different parts? 3 plus 3 is 6, plus 1 is 7. So 28 divided by 7 is 4. So if he needs to make 28 tons of cement, then we multiply each of these by 4. So he needs 4 tons of cement. 3 times 4 is 12 tons of sand. And 3 times 4 is 12 tons of aggregate. Another way that you might see ratio is if you're dividing up amounts. So for instance, Anna and Michelle invest some money into a business. They invest £5,000 altogether at a ratio of 2 to 3. How much does Anna invest? So the first step is we need to see how many parts there are. So we add the parts of the ratio. So we've got 2 plus 3 equals 5. Now, if we share the £5,000 between 5, that means each part is equal to £1,000. And we know that Anna, she's first, Anna and Michelle, so she's 2 to every 3 of Michelle's. So if 5,000 is the total, and we know that one part is 1,000, Anna is 1,000 times 2. So Anna is investing £2,000, whereas Michelle is investing £3,000. And we can check that's right because 2,000 plus 3,000 equals £500. Ratio can also be seen on plans and maps. Sometimes it would look like this, 1 centimetre to 75 centimetres. So this means that for every 1 centimetre on this drawing, it is 75 centimetres in real life. Other times, units aren't stated, so it doesn't state miles or centimetres. So no matter what you choose to measure with, you need to keep the units the same. So for instance, here is a map of an area in London, and it says the ratio is 1 to 2,000. That means if you measure 1 millimetre on the map, this will equal 2,000 millimetres in real life. If you measure 1 centimetre on the map, this will equal 2,000 centimetres in real life. If you measure 1 inch on the map, this will equal 200 inches in real life. So this ratio here tells us how the units relate to one another, no matter which units we decide that we want to use. So to summarize, we've covered percentage changes, finding the percentage of a number compared to another number and finding the original value after a percentage change. And then we've looked at ratio as a proportion in terms of sharing amounts, and finally looking at scale. If you could please look at the recording on number part A in conjunction with this. There are also activities that have been put together to ascertain how well your learners have managed to take in the information. They are relating to percentages and ratio. There are also, if you do need them, there's very good contextualized activities relating to percentages on the Skills Workshop website and also BBC Bitesize. There are also past papers available on Qualhub, and I would strongly advise that you go to Qualhub to take a look at these. Thank you so much for your time. If you do have any further questions on the content of this recording, please contact me by email. My email is charmaine.phelps@ncfe.org.uk. Thank you.